Morning, everyone. Sorry I couldn't be there with you today. Today we're looking at the sine law. Hopefully this question, I want you to take a look at it. Can you solve this triangle using SOHCAHTOA or Pythagorean theorem? While you're looking at this, I'm hoping you're thinking, well, this isn't a right angle triangle, and you can only solve right angle triangles using SOHCAHTOA or Pythagorean theorem. Because there's not a 90-degree angle anywhere in that triangle, we can't use either of those, and this is where our sine law comes in. Once you got a chance to put that in your notes, make sure you pause the video if needed and move on to the next example. Our next example, we're looking at the definition of sine law. Sine law is used when we have non-right angle triangles and only when opposite sides and angles are known. So when we have our triangle here, ABC, and remember, big A's, big A, B's, and C's, those are our angles. Little A, B's, and C's, those are our sides. And remember, side angle have to be opposite to each other, so angle A must be opposite to side A, angle B must be opposite to side B, and angle C must be opposite to side C. And that's the case for every single triangle. So when we have our triangle here, it's a non-right angle triangle, our sine law, we have our ratios using our opposite sides. So sine of angle A divided by our side A, that gives us one ratio. We also have a ratio of sine B divided by the side, little b. And our last ratio of sine angle C divided by little sine C. We can also have the exact same thing, but our sides and sine A's and B's and C's flipped. So we can have our side on top and our sine of our angle on the bottom. So those are our two formulas for sine law, and we can use one or the other. It doesn't make a difference. Typically what we're going to do is we're going to have our unknown variable. We're going to put that in our top left of our equation so that it's easiest for us to solve for in terms of rearranging our equations. And remember, when we're using sine law, even though we have three ratios equal to each other, we only use two out of those three ratios to be able to actually solve for a side or an angle. If you still need time to write this down, please make sure the video is paused. The next thing that we want to look at is a couple different notes about using our sine law. I've already said this one. Capital letters are always our angles, and small letters are always our sides. The next note is that angles always must go with our sine, and sides always go by themselves. The last note is that sine law can only be used when we have side angle pairs that are opposite. And that means we have to have a pair here, sine A opposite to its side A. We have to have one of those pairs known and at least one part of a second pair known as well. Again, to give you a chance to write this down, please make sure the video is paused. I'm going to move on. Example number 2, we're given a triangle with some measurements and we're asked to solve for x, and we have to round our answer to one decimal place. So looking at our triangle, we want to pick out what opposites we have. Typically, I always look for what is the opposite that we know. So we have this angle known here, this 65, and we also have this 9 centimeters known here. That is an opposite pair, and that's our known opposite pair. So let's throw that. Actually, let's not. Let's find our other pair first. Our other pair, we have this x here, that's the unknown, and that's what we're trying to solve for. And across from it, we do have its angle, so that is our second opposite pair. Now that we've identified our two opposites pair, let's put them into the equation. So our first pair here with the x's, because that's the unknown variable, we're throwing that in the top left corner of our equation. So x is over top of 52 is an angle, so we must put a sign with it, sine 52. That's our one ratio from our green pair. Then our other ratio is from our red pair here. Because x was on the top, that means that 9 has to be on the top, because all sides must be on the top, or all angles must be on the top. So then our angle is 65, so we have sine 65. Now once we have this put into our sine law ratios, all we need to do, because we put our unknown variable in our top left-hand corner here, is to get rid of this sine 52 is to multiply it to the other side of our equation. So what happens when we multiply that to the other side is it just gets multiplied to the top of that fraction, so that we get 9 times sine 52 all divided by sine 65. With this, I have a quick note. So with this note, please make sure that you leave sine 52 and sine 62 in your calculator rather than typing it in your calculator and writing out the decimals. The reason for this is otherwise we're going to have rounding errors, because you're not going to be writing out all the decimal places, or you might make a mistake when you write them out and have to type them back into your calculator. It's better just to do it all at once in your calculator so that there are no rounding errors. So please pull out your calculators, type this in, please make sure you're getting the right answer. Sine 52, multiply it by 9, then divide it by the sine 65. Your final answer that you should get is 7.8, and because our side was measured in centimeters, that means we're going to throw our measurement of centimeters on our answer. If you still need a chance to keep writing this down, again, please pause the video. Our next example here, example number 3. Again, we're asked to solve for x. And again, we're asked to round to 1 decimal place. So the first thing, identify your opposite pairs. So the first one, we have our x, that's what we're asked to solve for. We look across from it, we do have our angle at 52, so we can write our first ratio, our first pair, x divided by sine at our angle, which is sine 52. The next piece that we need is we need our known pair, where we know both pieces. So let's look back at our triangle. We know this angle here, which is 58. But when we look across, we don't know what this side is. So that is not a known pair. Let's look at our other piece. We have this 10.5 here, and we look across from it, but we don't know what this angle is either. Does that mean we can't do this question using sine law? I'm hoping that some of you are thinking that, oh wait, there is a way we can find that angle for our blue known pair. We know 2 out of the 3 angles, so what is it that we use to find that additionally third angle? That is our 180 rule. Remember, all 3 angles must add up to 180. So if we take our 180 minus our 58, and minus the 52, the two angles that is known, we will find our remaining angle, which happens to be 70 degrees. So we can now put that into our triangle. We know that that angle is 70 degrees. Now that we know that angle, we have our known pair with our blues here, so we can throw that into our equation. 10.5 on the top because sides are on the top. And then sine of our angle on the bottom, so sine 70. Again, because we're always putting our unknown variable in our top left-hand corner, all we need to do is take this bottom here underneath the x and multiply it by the top of our equation on the other side. So x equals 10.5 multiplied by our sine 52, all divided by the sine 70. Again, please plug that all into your calculator at once. Don't put the decimals on the page. When you type that all into your calculator, you should get the value of 8.8. If you still need time to write down, please pause the video at this point. Our next example, example number 4. This time we're asked to solve for theta. Theta is an angle. Remember, whenever we solve for angles, we round to the nearest degree. That wasn't written in the question because that's expected that you know this. I'm just writing it down again to remind you, and so that when you look back at your notes, you have that note there that you have to round to the nearest degree. Looking back at our triangle here, let's pull out our pairs. What we need to find is theta. We look across from theta. We do have that opposite side there, so we can use that as our one pair. We don't have to find anything else. Let's look at what else is left. We have our angle 65. Across from it, we have our side 16. So we have our two pairs. Let's throw them into our equations. Now this time we're looking for an angle theta. Because we're looking for an angle theta, we're going to put that in our top left hand of our equation. But remember, it's an angle, so it has to have sine with it. So it's actually sine theta. Then we divide that by its side, which is 15, equals our other pair. We have sine 65. And now this time, because our sine was on top with our unknown, our sine has to be on top as well. That always has to be consistent. Divided by the opposite side, 16. Now that we have our equation, the 15, it's on the bottom, so same rules apply with this. Because it's on the bottom, to get it to the other side, we just multiply it to the top of our other side of the equation. So that sine theta is equal to 15 times by sine 65, all divided by 16. Now you'll notice that I threw this 15 in front of the sine 65. The reason why I did that is some students will make the mistake of thinking that they can multiply the 15 by the 65 and then apply the sine button. That is incorrect. You may not multiply that 15 into the value of the sine. It has to stay separate. So that's why I put the 15 out front, to remind you and also to remind myself that it has to stay out front. The value is sine 65 and then is multiplied by 15, and then we divide by 15. Our last step to get theta all by itself, we now have to get rid of that sine. Remember, to get rid of the sine, we do the opposite, which is sine inverse, sine with that little -1. And again, we're going to do that with our entire value here in our fraction, so that we're not trying to carry out a bunch of decimal places or retype it into our calculator. So do it all in one step. Figure out sine 65, multiply it by the 15, divide it by the 16. Once you have that overall value, then press your sine inverse button on your calculator to get your final answer. So our final answer for theta. And we're rounding to the nearest decimal, or to the nearest degree here. Gives us theta is equal to 58 degrees. Please make sure that you always throw that degree symbol with your angles. If there's a time that you still need to write this down, pause the video at this point in time. Our last example here, example number 5. Again, we're asked to solve for theta. We're given our different pieces in our triangle. So let's pull out our opposite pairs. Let's start off with our unknown of theta. We look across. We have our known side here. Our other pair, we have angle 52. Across from it, we have our side 17.3. We have our two pairs. Let's throw it into our equation. Thetas are unknown, so it goes in the top right hand. And remember, because it's an angle, we have to put that sign with it, so that it's sine theta. Then its opposite is the 19.1. For our other pair, we have sine at 52. Again, it must go on top, since in our other ratio, sine was also on top. And it's divided by its opposite side, which is our 17.3. Now that we have our equation, the 19.1, it's on the bottom, so multiply it by the top of the other side. So that sine theta equals 19.1 times by sine 52. Again, it's out front, so that we don't forget to just multiply it by the entire thing. And our last step to get theta all by itself, get rid of that sign by doing sine inverse. Type that all into your calculator step by step, then do your sine inverse. The answer that you should get when we're rounding to the nearest degree should be 61 degrees. That's our last example of sine theta. You have some homework questions to look at. Look at the communication question number 1. For numbers 1 to 3, do only A and C for each number 1, number 2, and number 3, and then take a look at number 6. You'll also get assignment number 14, part 1 on sine law. Because I'm not here today to help you out, if you have any questions, instead of it being due at the end of class, it'll be due tomorrow, so you'll have a chance to ask me questions before you hand it in. Use your class time wisely, you can more than likely get most of that done. I'll see you guys tomorrow.